where Keith is the manager of an auto care center. Based on service records from the past year, the time and hours that a technician requires to complete a standard oil change and inspection follows a right skew distribution with a mean of 30 minutes and a standard deviation of 20. For a promotion, Keith randomly selects 40 current customers and offers them a free oil change and an inspection if they redeem the offer during the next month. Keith budgets an average of 35 minutes per customer for a technician to complete the work. Will this be enough? So essentially we have to calculate the probability that the average time it takes to complete the work exceeds 35 minutes. So here they're asking us about the average of a sample, which means we're going to have to look at the sampling distribution. So what do we know about the population distribution? The population, so all customers, it's skewed to the right, has a mean of 30 and a standard deviation of 20 minutes. So we're going to use this information to determine the characteristics of the sampling distribution, which means we're going to check the conditions to see the shape, and we're going to check the 10% condition to see if it's if we can find the standard deviation. Since the population of all customers is centered at 30, the sampling distribution will be centered at 30 as well. The 10% condition, we took a sample of 40 customers, so multiply it by 10, that gives us 400. So we just have to assume that 40 is less than 10% of all his customers, or he has more than 400 customers in the population. Now we can find the standard deviation. The sampling distribution of X bar will be centered at 30 with a standard deviation of 3.16. Remember, it's the population standard deviation divided by the square root of the sample size. And what shape will the sampling distribution be? The population, they said, is skewed right, but because of the central limit theorem, our sample size is greater than 30, it's 40, which means the sampling distribution will be approximately normal. So the 10% condition is met. The central limit theorem is met just because our sample size is large enough. Now we can sketch a picture of the sampling distribution and estimate the probability that it takes longer than 35 minutes. Here's what the sampling distribution will look like. It's normal, centered at 30. And we want to know what's the probability that the sample of 40 has an average time longer than 35 minutes. So I've drawn a 35, and I'm just going to use a normal calculation statement using these two measurements of center and spread to calculate if it's greater than 35. And we get a probability of 0.0568 from 35 to positive infinity with the mean. And don't forget, the standard deviation is not 20, it's the sampling distribution standard deviation. So there is about a 5.7% chance that he has not budgeted enough because they would be greater than 35. In this problem, they asked us, what's the probability of getting a sample mean greater than some value? In this next problem, they're going to ask us something different. How much average time per customer should Keith budget if he wants to be 99% certain that he doesn't go over the budget? So to help understand this problem, I'm going to draw out the sampling distribution, which is the same as it was here, but now I'm going to label out 3 standard deviations above and below the mean. This here is the sampling distribution. It's the same as what we were using before. I've already checked the large counts and the central limit theorem, or not the large counts. I've already checked the 10% condition and the central limit theorem. So it's centered at 30, and I just added the standard deviation 3.16 3 times and subtracted it 3 times because we know that 99.7% of observations, or of X bars when the sample size is 40, will be between 33 and 33.48 and 20.52. So that's 99.7. 95 are between these two values, here to here. 68 are between these two. So this question is asking, what X bar does he need to have to be 99% sure that he won't go over budget? We won't go over what he's budgeted for the time. So what he wants to know is, what is the X bar that is greater than 99% of all X bars. So think about this. If he had a sample of 30, that would be greater than 50%. If he had a sample of 36.32, well, this is 2 standard deviations above. So it's 95% plus 2.5 more. So this is above 97.5% of all observations. So he's looking for the X bar that's in here somewhere. This is what he's looking for. He wants to know what X bar is going to be above 99% of all possible X bars, because then he'll be 99% confident that he won't go over budget. So we have to, instead of in the previous problem where they give us an X bar and we calculate a probability, now they've given us an area and they want to know what X bar is this, what percentile is this. So we just have to go in reverse and do our inverse normal calculations in the calculator. To get the sample mean, that is the 99th percentile, we do inverse norm where the area is 0.99, the mean is 30, and the standard deviation is 3.16. These were all taken just from the previous problem, and you should get a sample mean of 37.4 minutes, which means to be 99% confident that he budgeted enough time, he should budget 37.4 minutes. He should budget for, or should plan for 37.4 minutes to be 99% sure he won't go over budget. Another way you can solve this problem is to convert these to their z-scores. And I just want you to be familiar with this method, even though it's not a requirement for this. It's just a good reminder here to think about the fact that each of these values has a z-score. For example, 30 has a z-score of 0 because it's 0 from the mean. 33.16 has a z-score of 1 because it's 1 standard deviation above the mean. And we could instead, like you'll see in the book, they like to find the z-score and then calculate the sample mean from that. I'll show you how to do that as well. Like I said, the z-scores, -3, -2, -1, 0, 1, 2, and 3. Those are all from the 99.68, 95.9.7 rule. But to find this z-score, which is between 2 and 3, we'll do inverse norm where the area is 99%. The mean of the standard normal curve is 0, standard deviation is 1. So if I put this in the calculator, it will give me a z-score of 2.33. Then I can use the z-score to find X bar. So the z-score for this would be the observation minus the mean of the distribution divided by the standard deviation of the distribution. And so I can plug in the mean and the standard deviation and then simply solve for X bar. So plug in the mean and the standard deviation, solve for X bar, and you'll also get 37.4 minutes. Go ahead and do the practice problems here and check your work with mine on the notes.